Hey, in this video, I want to show you a software that really helps your documentation look professional. Well, I'm providing services to a company and I talk to their mechanical design engineer. And so I need to generate documentation that's really useful and not just 2D. So I'll show you how Blueprint PCB really helps with creating your assembly documentation, fabrication documentation. Also helps the mechanical person just figure out what's going on with your printed circuit board. So with Blueprint PCB, this is from Downstream Technologies, and then you can launch the document wizard or something, right? And you click next. You can select your system, Altium, Cadence. Let's go with Cadence because that's what I'm using. I use both Altium and Cadence, but let's do Cadence. For the file import type, see, compress ODB++ is great. So let's go with that. Why ODB++? Because ODB++ is, it has intelligent data. Okay. So if we go in here, I like to use this project. We go Allegro, and then, I could do IPC, but let's go to ODB, and it has a TGZ extension. There's a complementary ASCII if you generated that, but let's not do that. What's great is I can import the ODB++ folder too. Once you've exported it from Cadence or CAD Allegro through the extension, their ODB++ extension from a different company, it'll generate a folder or a zip. Anyway, let me not get distracted or confuse you. So hit next. And do we want fabrication on a sheet? Yes, we want fabrication so the manufacturer, the engineer who's in the manufacturing side of things when you submit your PCB knows what's going on. Also for your client to review your work. Assembly, yes. If we want to know where the components go on the printed circuit board. So yes, we want a sheet border. Looks nice. The sheet border helps us point to locations on the sheet. You'll see what I'm talking about. And then the title block. Continuation block and revision block, sure. Click next. Number of sheets for fabrication. See how it goes down here? How many sheets do I need for fabrication? I'd say I need 1 sheet. And I want the drill pattern. I want the drill chart. Let's stack up everything. Next. For the assembly, how many sheets do I want? Assembly is different. I'm going to need multiple sheets because I'll have a components list. So maybe 2 sheets, maybe 3. Do I want the top side view and the bottom side view? I'll just take the top side because I know I have no components on the bottom side. But you may still want to do, actually, you know what? Let's do top side and bottom side. You always do top and bottom. Others, parts list and assembly notes. Click next. And you always want to have too much information as opposed to too little. For the release package, you set your folder and use for wherever you want the package to be at. Specify the file name and location of the release package. Sure. Click finish. Okay. The release package has been successfully created, but there were errors during the import. Do you want to view the error report? Sure. And I will use that to open text files. Okay. Not sure what happened there, but hey. So this is the design, the ODB++, and then this is the 3D. See, look at that. Looks great. And you can see inside the layers there too. I'm actually kind of happy that it didn't generate. Oh, no, it did generate. Okay. I was going to say, I was kind of happy that it didn't generate the drawings because then I could show you how to manually generate these. But I can still show you that anyway. But first of all, take a look at how nice and professional these drawings look. I mean, come on. This looks fantastic. You can hold down the control key on your keyboard. What I like about Bluestream or Blueprint PCB is that it just makes like this. I can't explain how much time this saves, especially when you can do your notes, your design notes, and then you can say what width and size you want the text to be. It really provides a great complement to the OrCAD software, or any software for that matter. As long as your ECAD software can produce ODB++ or IPC 2581, files for your PCB, this software can handle it and create very professional looking and professional documentation. It makes it easy. And then you can fill in information like it automatically fills in information for you. You can add stuff like right clicking and insert a note and then say must have I don't know, conformal coding on the top or something like that, and that's good. And then you can even add some things. For instance, if you want a common call out, and then you put your call out here, and then the call out can be insert a reference. You insert your reference here, and then your reference would come from notes on otherwise specified. It looks like it isn't really updated, but this new one. All right, see these other notes. Select or choose the conformal coding option. You can zoom in and zoom out to change your view. Click OK, and boom. Look at that, man. Listen, this is the sauce, okay? All right, so hold down the control key to zoom out. I don't like this pan zoom thing. Like if I do my middle mouse button, and I don't like this rectangular pan. It's really annoying, actually. I never use it. So anyway, the description. So you can fill in the description and say this drawing was created, or you just put in created. And then you can do, I wonder if you can do Control E to center this. Nope. But if I select the text and choose format and choose center, it does work that way. But see what happened there? It centered this too. So let's Control Z. I think I selected. Let's zoom in. I'm here acting like I'm about to submit this for real to a designer. But anyway, this is how you do it. Date. What's the date? 2020X. And then approved, so on and so forth. This is how we do it all the time. You know how it goes once you're in engineering and corporate. All right, so there's the parts list. Very nice. And then the parts list will extend. And then this is a little tricky. But it's okay. There's some overlap, but that's fine. And then you can, I don't recommend removing the title block. I mean, the title block for the sheet. For this other sheets, you can delete the sheet. And then see, it says sheet 1 of 1, and it mentions the scale as well for the drawings. Now let's zoom in here on the drawing. This is the fabrication drawing. What considers this a fabrication drawing? The fabrication refers to anything that is required to actually build the PCB, regardless, like minus the parts. Assembly drawing shows you not fabrication for the PCB, but where you can place the parts, or where the parts need to go. I have boxes here for my test points, but that's because I defined a certain area around the test points, like keep out areas, package areas for the test points. Test points, by the way, need to be about, ideally, 100 thousandths of an inch away from other test points or any other object for that matter. Ideally. But they can be as close as 50 thousandths of an inch to other things. I don't even know why I'm talking about. What am I talking about? Anyway, magnified detail. So if you want, you can go on here, right? And then zoom in. Control Z to zoom. And then you put your little circle on an area. And then you expand and move around your big circle to blow up that area that the little circle is pointing to. If we want a dimension, you can do tools or draw, actually. Yeah, it's draw. And then you can auto dimension. So what's auto dimension? You just click on something like an edge of the thing and pull. You have to hold down and pull and drag. And then pull down, click, drag, and hold. And there are your dimensions there. You also want to show the dimension for where your mounting hole is. So how do you do that? Right? You have to get out of auto dimension. Right, with the right click, you end your mode and go into draw, and instead do something like add a horizontal dimension, something like this one. Click. See, there you go. You have to click, hold, and drag. It's a little weird. I prefer the 2-click method, honestly. To select my starting point, don't have to drag anything. Select my other starting point. Then you have the drill table. Right, and then the original origin, you want to select this and zoom in and put it where it's supposed to be. Exactly where it's supposed to be. Put it like there or something. You always have to mark the origin on your drawing. There is just a lot that goes into this thing. If you want to panelize your drawing, you can do that. You have a panel for your PCB and then generate the panel drawing. There's the templates you can use, and let's see, there's something really cool I want to show you though. For assembly, let me show you this, and I'll end on this note. Add the 3D PCB assembly, and look at that. You can change the scale. Let's see, look at it. Beautiful. And then you can right click. You can do any angle lock or edit the PCB view. You can use your left mouse button to change the view to whatever you like. And then when you go back to your preview of the PDF, this is how it looks. If you want to edit the PDF of the drawing, this is how it looks. So it's good. It's good. So this is the edit. This is where we were editing the whole time. This is the preview of the drawing itself. What the client is going to get once you print this out. This is the design, the ODB++. What layers we want to turn on and off. This is the 3D design. Yeah. And then this is the start. Once you're satisfied with this, maybe go to preview, and then you can go to file, save as, and it has its own name, right? So we'll call this PCB test. I like to use test for everything. I don't know why. Click save, and then go to file. Then you can export a PDF. Do we want the original? Yes. The original is size C paper. I'll call it Fabrication Assembly 2. Save. And so yeah, the software tool is pretty smooth. And there's, okay, how do I say it? It's pretty good. It's very good. And there's some slight jitter I've noticed when zooming in and out. I don't know if it's just my machine or that's just how it is. Notice how the mouse blinks every so often. So I'm not sure what that's about. And the stack up visualizer, I can visualize the stack up. So that's very, very good. And I can collapse the cores, show layer labels. It's very nice. Export the stack up if I want to into an XML format, IPC 2581. That's a IPC standard. Which units do I want to go with, or do I go by copper weight? This tool is extremely diverse, and if you're really like a company, you or an engineer, you don't have to use these kind of software, right, to generate drawings. I can generate drawings in PCB editor, but it's not going to look anywhere as nice. And if I want it to look just as nice, it's going to take me a much longer time. Okay, now that I have found the PDF, this is how it looks. This is what your CAM engineer gets, or your whoever the PCB stakeholders are. This is what they can see. Looks great. You want to make sure that you add dimensions to pretty much everything. I said pretty much a lot, I feel like, or very good. But hey, it is what it is. Very good and powerful software. Highly recommend it. And yeah, it'll help you with your documentation process immensely. Alright, thanks for watching. If you have any questions or comments, let me know. And I'll see you next time. Until then, keep on designing.